All right, here we go. Okay, wait, I thought I usually. Oh, yeah, I'm right there. Okay, there. Good. All right, here we go. Here's the moon. All right, so now we're into the notes. Let me move this thing. Okay, so we have our graphing calculators out. We'll get to it. Pretend you did your beep boop bop boop and did your regression. Silence over there. Your little conversation. Okay, should be sorry. All right, here we go. That is okay, this is what, so we can get our terminology down. This is actually called, this is the regression. What a regression is a model. But what we're going to call it is the prediction model. And I should have maybe been saying that all year long because this is why we do regressions. We want to get data from the real world. Hey, let's do that right now. If you want to change colors, fine. If not, these points are actual data that I collected from maybe an experiment, a survey, whatever. And I don't want to I guess that's okay going through the model there. Those are actual data values that we collected some way, shape, or form. And then what we want to do as mathematicians, look at the data on a graph and try to pick an equation that matches it. So then later, whatever 7 represents, what would 8 give us? What would 9 give us? What would 10 give us? That's why this is called a prediction model, and that's what we've done with regressions this whole year. We've used the model to answer questions, okay? And that's what we should understand about regressions. That's why when anyone that might want to be a business major, you will take business calc because businesses collect data on their product and they try to analyze, is it working or not? Do we need to make changes? What's the predicted future of our income or costs or whatever? It's all math. All right, so that's what we need to understand. That's what a regression is, so then we can use some of our terminology to help us today. Okay, so let's talk about what a residual plot is. Can everyone say residual plot? Did you hear them? Okay, that's a good class. Do you think? No, I won't say it. All right. Okay. Oh, was that in the? Oh, okay. I forgot I have a picture here. They didn't say a word. Nothing to me. Yeah. Okay, so what's a residual value? Here's what I want to do. I like this point the best. Hey, look at 7 comma. Oops, sorry, I should color this red. That's the model. The model says 7 comma. Now, unfortunately, it's not going to match when I show the next page. There's a problem. It's no big deal. But wouldn't you agree that it looks like 7 comma 100? That's what the prediction is for 7. But what's the actual data? 7 comma what? 120. So that's what a residual is. How much is your model off of the actual data? That's it. That's what a residual value is. So in this case, it'd be 120 minus 100, which is 20. Don't write that down though, because I want to write this down on the residual plot. So anyway, what this is, that's what a residual is. A residual is the difference between the actual data point and what the model predicted the data point would be. So we can only do this with the actual values that I have. Okay, now, here's what doesn't match. And I wish it did, but it's supposed to. This graph is supposed to match this right here. Now you have to go to the next page, but it doesn't quite do it. And I'll show you why. It's that one point I noted. But do look at this compared to my graph here. Look at the first data point. That first data point, can I see myself pointing in this screen? I know I have the screen probably pretty small, but I do like showing what's happening in class. Isn't that first data point above the model, right? Look at this residual plot. It's above. Look at the second data point. Isn't that below? Then above, then below, then above, then below, then above. Got it? What doesn't match is this. This is what I don't like. Because in the notes they say these match and they don't. Shouldn't this be 20 above? Not like right here, right? So there is a mismatch there, all right? But don't worry about it too much. Just pretend we're looking at this now. Here's what you got to mark. Here's what a residual plot does. This now, you need to draw that. That is the prediction model. The y equals 0. It's the prediction model linearized. And you know what? The flip math people, this is why I'm making my own video, do explain this. I just want to really get direct to it. And I do want to use the word linearize. And they may use that word, or I may have, I don't know. Don't remember. I should have watched that video again this year. Okay, but it's linearized. And all it's doing is, hey, okay, fine. I know I have some sort of graph. I just want to see how far off the actual data points are. And I'm going to put this again. Oh no, I think I got the colors right compared to up there. These are the actual data points. All of these. And this is the prediction model. Linearized just at y equals 0. And then all you got to know is, you know, what's happening here. So what's the model doing here? Let me throw two words out at you and you tell me. What's the model doing here? Is it underestimating or overestimating this actual data point? And where I pointed, if you couldn't see on the thing, is this right here. So what's the model doing? Underestimate or overestimate? 3, 2, 1, go. Pick one. It's under. What's the model doing for this point? Under or overestimating? Over. What's this one doing? Under. What's this one? What's this one? What's this one? What's this one? There you go. Isn't that fun? Now, it's not always going to be like that. By the way, bless you. I guess I'm the only one that cares. I'm just going to do sneezes and everyone just looks at him. All right. Cross this off. And then in your homework, you're going to have to change something. Okay, and I forgot to do this. And actually, I'm going to change it right here. We're not going to do error. Error is just the reverse of that. It's the opposite of residual. So cross this off here. Oops, and just put residual. And in your homework, put residual wherever there's error. And then your answer will be opposite, like opposite sign. Because all error is model minus actual, or predicted minus actual, not actual minus predicted. It's stupid. We have enough going on here, unrelated topics, that we just want people to get the main idea. Oh, you know what we got to do? This is why I told you to get your calculator out. Now what we're going to do is, and I think I'm done. Yeah, I'm done explaining those terms. Those are all the words that we need to do. All right, so I'm going to slide this over here, and I'm going to open up the calculator. You guys, whatever you use, I think my 5th hour, the most, the hour that's getting the best grades have the most graphing calculators. Interesting. Okay, which was a prerequisite for this class. Clear. Okay, you know what I'm going to do? I'm going to do a second MEM 712. Reset your calculator. I've had you do that on your own. You probably do want to do that so that you hit your one button. All right, I was mad at 3rd hour. 4th and 5th, you were a little better on our last test knowing these buttons. Stat, edit. That was number 1. Type in the data. Go ahead on your little Desmos and type in your little... And if you're sitting there licking the walls during this, this is why you don't know how to do this on the last test. You infuriate me when you sit there and just do nothing while everyone else is bebopping and hitting their calculator. And you're about ready to saw logs. Anyone know what saw logs means? Nobody? Snoring in class, sleeping. Never heard of that? Saw logs? Did you type all that in? Then the next thing, the yawn, I just brought up sleep. The next thing is you hit the same stinking button. Stat. Now wait, I got to read the question. Find a linear regression curve. This is all you had to do on the last test. You didn't have to plot the data. You didn't have to look at our squared values. You just needed the equation. Stat, move over. And it said linreg, we like 4. 8 is also a linreg. I don't even know why it exists. Fine. Now, people that have an older calculator, I don't know if that's this class. Do you get the same menu that this? Okay. Just got to check if there's older calculators out there. Fine, everyone's in the same spot. You got to stop here, though, because I got to get this in Y1. We all have upgraded calculators, I think, in there. If you don't, it is vars, Y-vars, function, and then you type Y1 there. So that's a lot. I get it. All right, but you just got to figure it out. It ain't that difficult. Or alpha trace. gives me and alpha, all of these things gives us all of these special things. This is for matrices. I thought I hit alpha zoom. Let me see. I thought that was did I hit that right? Let me see, window. No, it didn't go. Zoom. Why is that not changing? That's wild. Alpha zoom usually is matrices. That didn't come up. But anyway, I got myself distracted there. And then I guess that doesn't do anything for alpha graph. But alpha trace, I got to get out of that again. So I could quit. Okay, and I got to start all over. Stat, calculate, jacking around too much. 4. Got to go back down. Enter, enter, enter. Alpha trace Y1. Okay, so that really is just one button. I was just messing around with features. Boom. So why don't I have an R squared value? Because I cleared my memory. We don't need it anymore. You know what I am going to do, though? I'm going to come back over here because I like typing on the screen. You don't have to do this. Just watch. Because it is and can be catastrophic if you turn your plot on and you don't have any data values. Your calculator will shut down and never be able to graph. So be careful. Tread lightly. And then I also, this makes me mad, students that think this is hard. Okay, because it isn't. Look at my X values. They go from 50 to 300. So my window should cover a little bit more than that. So I went from 0 to 400. And then the Y values go from 20 to 126. 0 to 200 covers that quite sufficiently. This is not rocket science. What I wanted to see is to exercise terminology. First of all, is this line a good fit for the data? What do you think? Yes or no? Yes or no? Kind of, yes. What would your R squared value not equal? But it could be close. What is it supposed to equal? 1. But I bet you it'd be 0.9 because this is pretty decent. Now, let's point at the very last point. I don't know if you can see me in this. What is the model doing? Over or underestimating the data point? Under. The model's under the points. This is the terminologies you're going to have to use today. So that's why I wanted to go over that, just to understand terminology. Okay, you know what I got to do? When I hit second quit, I lose that equation. So I got to do it again. Stat, calculate, 4. You know what? I already got it in the Y1 screen, so I don't have to do it again. I want to write this down now. 0.417. So y equals 0.417x. And then let me get that calculator back up. Minus 8.701 is good. And if you don't round to 3 decimal places, I'm marking you wrong for a lack of precision, a lack of reading. Whatever it is that makes you not write 3 decimal places is why you get the red pen of vengeance. All right, now, this is why I want to change this to residual, just because I don't want you to have 2 things to remember out of this. What's residual? The actual data point minus the model's data point, or what did they use for a term? Predicted. Predicted, which is the model. Let's use the term predicted. Understand that's from the model. Okay, what is the actual for 50? Well, here's 50. What's the actual output value, everyone? 20 minus, what's the predicted value for 50? I got to go to my calculator and get that. So how do I do that? Calculator. I got 2 ways. I'll show you the second way first. The way that I learned from the flip math people that I did not know existed. I can do y of 50. Now, I'm going to press enter. If you get nothing, you're up. You missed the point of where I had to put y1 to store the equation in y1. This is why this doesn't work. I had people ask me during the test, and I'm not going to answer because this is what you were supposed to know. That's what I'm testing. Do you know how to use the technology? So I think some of your teachers in the past have enabled you, teaching you on the day of a test because you didn't learn it. When that's what you're supposed to be demonstrating on the day of the test. Do you see? Do you see the insanity of that? Okay, that's a problem. Here's another thing. Second, calculate value. So I can also do it in this graph as long as 50 is in my prescribed window settings. Yes, 50 fits between 0 and 100 or 400. So when I go to the graph and it's second trace, by the way, second trace has been accessed all year long. Min, max, intersect. We've done this all year long in this menu. Shucks. Second calculate. I didn't hit value. Good thing I said shucks. Same thing. 12 point, what does that say? 1395. Let's teach them how to round. 1395 is 140. Okay? All right, now when I predict or when I get the residual, that turns into 7 point, I think 860. This is what the residual equals. So on the AP exam, if they want what is the value of the residual, that's what you put. This is why the error is a little bit better, because the error just reverses these two and would make this a negative, because then this next question is pretty easy, but it's still easy. If this is the predicted value and this is the actual value, what's the predicted value? An over or under estimate? Under. That's not hard. So it's an underestimate. The model underestimated the actual value. And that's what you have to go through when you're answering these questions. Okay? All right. So enough of that. Okay, we do have another one, though it's just not, not calculator active. This is a perfect non-calculator AP question. Perfect. Several cars were tested for braking distance. A regression model was calculated. They don't even tell you what kind of model this. I don't think it's linear. Think about a car. It's going really fast and it stops real fast. So that might be like, it might be exponential. We don't know. Doesn't matter. Was calculated with the car's weights as input values compared to braking distance. So obviously the heavier the car, probably the longer it takes to brake. That's simple physics. Unless you have different types of brakes that for heavier cars. Given the residual plot, has a point P at this coordinate, what does point P indicate in context? Mark it up one more time. Remember, this is the model. That's the prediction model. It's linearized. And then they say what the coordinate is, but they also label it. So guys, it's real simple. What's the model compared to the prediction point? An over or underestimate? It's an over because it's above. So what this means is the model overestimates. Actually, you say the actual data point. I guess at P, I don't know, at point P, whatever. Okay, and then this would be a perfect multiple choice question, and it probably will be. High likelihood when it comes down to the AP exam. Okay, now this is where this gets weird. This is where I lost some people last hour. So should we get up and do some jumping jacks to reset our brain so we can really focus on this next part? Okay, because this is what you got to understand then. One more time. What's a residual plot? This is the actual graph. That's the actual graph. It's linearized. It's the actual, we'll keep using the word model. Model means graph, equation, to try to match the data. And my model moved a little bit. It's right on this line here. Okay, so this model could be anything. It could be exponential. It could be quadratic. It could be, it could be anything. So what I did last hour is I went back to an upside down quadratic. The only reason I did that is for the next one, an upside down quadratic. I can explain what's going on. So here's this point. So what it means is that point would be way below the actual date, right? And then here's this point. So that would be like right here. Here's this point. That means it'd be like up here. But then here's this point. That'd be right here. And then that's all this data would be like One's right on, so I tried to mirror that one. And then these would be like right here, above and below. Seems like there's more above and only, so a lot of them are here. But what I have to ask you is, don't these kind of look upside down quadratic? Yes or no? Wouldn't that be a good R squared value, but not 1? Yes or no? Right? So that's what that means. That's how you translate and you don't have to do this often. What I'm trying to do is climb into your head. This is what this would mirror if I was looking at this residual plot. So that means that residual plot is showing that this model is pretty good for the data. We'd have a good R squared value. Now let's look at this one. Let's slow down, mistress. Okay. So why I picked upside down parabola up there is this one really makes sense for me using an upside down parabola here. So again, one more time, a residual plot, that's the model. Linearized, the model could have actually looked like that in the real world. But a residual plot linearizes it. You know what this data would look like? All these points are way above. So they're like right here. And then they're getting close. One's right on. That's that point. And then some of these are below. And then they are above again. Look at, like, this point is way far away from the model there. So what I kind of could do is, this data is probably linear. And we tried an exponential upside down to mirror it. And it doesn't do a very good job. Right? I mean, this would be a horrible R squared value. So this is how this would translate into a residual plot. That means this residual plot means you have a bad model. Your model does not match the data good enough. So therefore, you should choose a different model. Same thing with this. Anytime we have a pattern that diverges from the model, this is a bad model. And even this is like that data, this should be more in the middle. Like, this would be better if this was here. And these data values probably skew off and keep going away and diverging away from the model. So any pattern that you see that's not scattered above and below nice and evenly is a bad model. Therefore, the residual plot shows that that's bad. So when you look at the rest of your homework, by the way, go to your homework, change this to residual, not error. I didn't do that in the other hours. And your answer in the key will be a negative number, but it's actually positive because I changed this. So just remember I said that. Right? But anyway, that's the same as our first example when we went to the calculator. Same as our first example. Oh, by the way, change this to residual, not error. Your answer on the key will be the opposite. If the key says negative, you should get positive and vice versa. And then the rest of these are just multiple choice. Super fast, super fast, super fast. Okay? That one's super easy. That's like the one that we just did, where I don't have to do any regression. It's all there in front of me. So, okay, done with the movie.